2 months ago, there was a large, I think one of the largest tenders in the world has been floated. It's a 200, it's 90 MGD at the moment, but the total demand would be over 200 MGD, which is the shortfall of Delhi, which is getting recycled through a very innovative method of treated water getting recycled through lakes, a series of lakes, and then percolating into the groundwater source, and then of course being drawn at some other source and then passed through a UF and RO and ozonation. So availability and affordability of these technologies has made it possible that these sort of systems can be applied. This is one of the largest projects, and in fact, we have also bid for one of the in this project, and it will be a game changer sort of for the country because it will be the first time that something of this size and scale has been tried out uh, with treating treated water, so to say. So my point, which I wanted to put to the learned panel here is that when we talk of smartness in water, are we only talking about the technology and the quality of the water, or are we also, and we should also talk about how to collect the data of where this water actually gets used, because now you have a lot of instrumentations like IoT and sensors. I was reading somewhere that even the temperature of water needs to be sensed. And in our country, that is not so much of a challenge at the moment, where the water doesn't, I mean, the freezing doesn't happen in most of the parts. It's only in the upper regions probably. But even hot water and stagnant water, there is a lot of, there could be some bacterial growth in water. So if the flow of water and the stagnation temperature can be monitored, there could be a case where that water, the information that we get from the data can be used smartly. Uh, so as long as we are able to use the information and data coming in through hardware and software, I think we will be in good stead. Of course, these are some of the points that I had. In case any points that you would specifically ask me for, my experience in terms of what we have done as a company, or since we supply membranes and we also, we get inroads into what other companies are also trying to do with the technology. I would be open to answering that. Thank you.
Thanks, Vikram. You have given us extra time to ask you more questions to understand your modules and businesses. I allow to the panel to ask the questions before I jump in with my questions. Other participants can definitely ask questions, please.
Sure. Yeah, that was a very valuable insight from Vikramji on the current state of water, and really, appreciate the time you are taking. You have taken uh, to describe the journey that you had. And one of the points that actually came out during the discussion is the preparedness that we have in our country to manufacture membranes. So do you want to say something about how good are we as a country in terms of manufacturing, any membrane, be it UF or RO? Do we have companies doing it? Do we have the necessary infrastructure? Because a lot of funding comes to academic institutions and other agencies to develop new membranes, but nothing is getting seen in terms of membranes actually being manufactured. The smart part comes later, definitely, but I was just trying to understand the basic infrastructure that we have today to make this happen.
Sure, Mr. Vijay Sai, thanks. Very nice question that you asked. Yeah, I'm totally with you, because when we took over the technology from Government of India in 2012, the salt rejection that we were getting was 93-94%, which was not the industry standard even by then. So in order to survive in the market, we had to import technical people from larger companies such as Dow, who came over to our factory, gave us the formulation, who stayed with us, for 6 months on a dollar salary, and then made our formulations. And so that is how we were able to achieve the 99.4 or 5% that we actually go to. We are not the world beaters in by any stretch of the imagination, because the infrastructure required to set up, in the world, there are not very many membrane manufacturing companies. The cost of setting up, I have been to the factory which makes the Dow membrane. The cost of setting up such an equipment or a factory layout is about 40 to 50 million dollars, which was not the case available to us here. What we have done is a very low cost, a true to Indian sort of, as we say, jugaad system, where we have used a very cost-effective method of making the membranes. Our capacity is also very limited. And you're right, absolutely. The number of membranes that get imported into the country, is I would still say it's 99% of the demand would still be getting imported, because the companies that are making the membranes are using most of them for their own projects, because that itself is large. If you look at the companies which are making membranes, most of us also have our own OEM division. So we get, like for us, for instance, we have RO plants on rent on a pan-India basis. So we run close to 2,800 RO plants in India, which are our own equipment, and we operate them on a per liter basis. So we got into this business because we were buying so many membranes from all countries, and we wanted to substitute that. So that is how we got into this business, and since then the demands have also gone up, and yes, 99% of the membranes come from, and plus mostly in the projects also it is spec'd as such. So if you look at brands also, it's only like in the project that we had in Delhi, we were able to convince them for some Indian brands also. I had a tough time when we started, I had to go and meet nobody in the States would openly, ask us to come and give our brand name. So I had to go using some, push and pull to chief ministers and ask them, there is a brand of membrane made in India. When you have other brands from Chinese and other countries origin, why can't you have these in the tenders? So they would also look at it with suspicious eyes and say that, okay, where is the membrane? No, because still till today, a lot of people don't believe that membranes have been casted and coated in India, whereas
Absolutely.
yes, so we are very open as a company. Company name is called Unique Flux Membrane. So we would invite people to, in all our inaugurations, we have had people coming in, and it's open. Normally, membrane makers are very secretive about the way that they do their processing, but we are very open to ideas. You know, People can come. In fact, our plant was inaugurated by the CEO of Thermax, uh, and of Praj, Mr. Chaudhary. So we were very open about asking them to come over and bring their customers, so that it's, you believe it, you see it, you believe it.
Absolutely. Yeah.
Yes. So the speeds are still low. What we are trying to actually gravitate now towards is not to be just a regular membrane manufacturer. There is a startup out of Bangalore which has approached us, where they have worked with some nano materials, and they have, on a lab scale, they have been able to generate 2.5 times the flux of a regular membrane. So now we are in talks with them to try and commercialize it at our, on our equipment, because we have only 8 meters. Our production capacity is 8 meters per minute of membrane fiber, of the sheet. So we want to maximize the bank. We don't want to get into the 5,000 or 10,000 rupee membrane market. We're trying to do something a little higher recovery. Since we are a boutique membrane manufacturer, also the advantage is that we have been able. Some customers have come with a special design of a membrane that they would like us to calibrate for them for paint recovery, for the dairy industry, for whey proteins. So 10 kD membranes or 5 kD membranes, so those are also some things that we have looked at and we have achieved.
Sure. Professor Abhilash, do you have any query?
Yeah, so just carrying forward this, a small question to Mr. Vikramji. So, what is the challenge that you feel in this membrane making? Is it the infrastructure, or it's the infrastructure or the technology, or it's the technical manpower that is lacking in India when we are talking about membrane manufacturing?
A very great, good question, Abhilashaji. Actually, it's surprising that although Dr. Sauri Rajan, who actually created the first reverse osmosis membrane in America, was of Indian origin, and we still have this challenge of having enough technical people. If So what I've seen is that people come to our company also, and they work as interns, or they are all technical people, maybe PhDs and all, and then after a few years they're looking for a job abroad. So they are in well sought after, and India is branded well in the membrane market. So they are able to get jobs with international membrane manufacturers. In India, since we don't have that scale yet, for the quality membranes, which I would say are used in projects. We have scale. There is scale being developed on the domestic side, where the membranes which are 250 rupees, you can use it and fill they are now replaced with like filters. On that market, there is some scale available, but for membranes in projects and difficult waters, uh, the market is there, but manufacturers are unfortunately not there. As I said, one of the key things is the infrastructure cost. I mean, for instance, as I mentioned, the $40 million for a infrastructure if you want to set up a membrane rolling, a casting coating like a Dow facility, whereas ours is much more rudimentary. So there is a lot of membrane making is not just a science. Now, I'm a commerce graduate, but I used to think that when you add two polymers, you will get whatever it is intended to be. But very very hard way that we learned over the past 10 years is that it's not always a science, it is also an art. So sometimes when you add two and two liters of one polymer, another 2 liters of another one, you won't get four, you get most of the time you get three and a half. And that is one of the key challenges that we've had, because our precision is not, we are not fully automatic. The precision levels of our equipment are not as good, and all membrane making equipment is a special purpose machinery. So in the world also, if you go, you cannot find a membrane manufacturing standard company which is making the equipment. It is all special purpose. Everybody has their own tweaks, and references are also not very many, because there are only 10 good quality membrane manufacturers in the world. So you can't even look around that much. So it's your own discovery process which is happening. For instance, now the sort of support that we are getting because of CSM CRI Connect is that Government of India is putting in some funds into desalination, and we are hopeful that because we are part of that network, that those funds will then effectively also flow to us, where we will be able to improve our membrane quality to the level which is acceptable for usage.
Good. I think we are closing in on the first round. Just I will close with some comments. I'm sure, Mr. Vikram, with so much of Atmanirbhar Bharat happening, production linked incentives being promoted even for semiconductor chips. So for defense equipment, I'm sure going forward with the government, with the kind of water stress which we are going to pass through and the kind of industrial growth which we are looking at, I'm sure you must also be pitching in or influencing the policymakers for production linked incentives for membrane manufacturing. The what you rightly when you said that there is no such much demand for high quality membranes, maybe it's time to rule cut it, because every industry is being imposed to go towards zero liquid discharge, and in a zero liquid discharge, definitely the first action comes is with RO, for the simple reason it is the cheapest of the other options available, and
Yes.
almost about 75 80 85% of recovery can happen from there. So I'm sure you know the market well, you know the business potential well, and you know the growth potential well. So we hope that you will get the attention of the government towards increasing the capability within the country on membrane management.
Thank
With
you.
that words, I think we will close in on the first round. So now I will call upon the next speaker. Just give me a minute, please. Uh, may I request Mr. Dr. Vijay Sai Prasad, who is the head of Water Technology Center at L&T Constructions. He is currently Dr. Vijay Sai is heading the Water Technology Center, which is the hub of research and development, digital technology and knowledge management for the L&T's water and effluent treatment business. He has over 25 years of experience in industrial research, commercialization, digital strategic positioning, and crafting product, productized services. So with this introduction and a small request to other participants also, if you can in the chat box put your contact details. It will be good for the others also get in touch with you so that we can note down on our own end. So I welcome Mr. Dr. Vijay Sai to take up the next round, please.
Yeah, thank you, Narendraji. Um, I really was so excited today to know in fact, to see the topic itself, because everything about the smart water system and the smart water management, and it is something which is the dire need of the hour now, and we are in fact taking the topic at the right time. And I was just trying to, in fact, look it from the L&T perspective. So, what's the offerings that we have, and where the smart solutions can actually come in? And we are already ahead in the game, and we have implemented some of the, exceptionally interesting technologies in our portfolio. But there is a lot to do further to save the water, which Vikramji just now mentioned about, and that is the main purpose with which we got to focus the savings and bring in the smart features to achieve those possible savings there. So when we look into the products that we are or the services that we are into as far as the water is concerned, so I would say that water and wastewater is one vertical that we typically work on, which has rural water supply. Getting the water into the pipes and then distributing it into the rural areas from the available sources. Of course, urban water and water management system is the second one that is taking quite a lot of attention. For a simple reason that we have a aging infrastructure as far as the water distribution in our country is concerned. But at the same time, we got to move forward and then convert this aging infrastructure into a sustainable one where the water loss has to be prevented. Now, today, 55% close to of the water that is being transmitted through the pipes are ending up in the losses. So non-revenue water is a big topic for us. So how do we move from the intermittent supply that we are now having in our country to a pressurized water system offering water 24/7, and subsequently be able to reduce the loss and bring it down to 20% from 55%, and then later down to 7%, which many developed countries have been able to achieve, is definitely a big topic for us to focus on. So whatever the smartness that we want to bring in through the measurements, through the controls, through the IoT systems, and through tracking the water, they're all very, very relevant from the urban water management perspective. The third one under the water and wastewater division we look into is the wastewater itself, which is basically the construction of the STP. India is at such a situation today that the regulations are quite good. We are on par with the US as well as the European standards as far as the regulations are concerned. But when it comes to discharge of water that is generated from the wastewater treatment plant, the monitoring has to be, aligning with the regulation, which unfortunately it is not. We only look at few parameters, and then that is not adequate. We got to in fact look beyond that, and then we got to and then we got to incorporate more parameters into our measurements so that the discharge water quality is on par with the regulations what we have in our country. That's subsequently we have been spending enormous amount of energy in treating wastewater. So it's not just about the process that we follow, but even the transportation of the water into a common treatment plant and the infrastructure that is required to make this happen. Everything is quite energy intensive. Is it the way that we will continue from here on? Because we know what the climate change is all about, how much actually the carbon emission leads to the climate change, and to cater to the energy requirement that we have. And water being such an important area, a lot of energy is being spent on the transportation of the water, distribution of the water, treatment of the water. So how do we basically turn this game around and then make the water treatment instead of the energy consumption system to energy neutral system to begin with. So that's another area which should be under focus, and then that is where a lot of smartness again has to be infused. So there is a way that we can probably separate out the treated material from the water, which we call as a sludge. There is a way that we can basically maximize the biogas from the sludge. There is a way that we can harness the energy from the biogas and use it back into the process to treat the water better. So there is a lot of opportunity, and we got to get smarter in terms of managing the whole game here, and then get better out of it. The second vertical, what I talked about, is irrigation and industrial infrastructure, which basically talks about large water systems. So this is all about collecting the water from the huge reservoirs and transporting it in through the canals, and the canals so that it is distributed to the farming purpose and other agricultural purpose here. So that is another topic which needs greater attention today, because the way we have been traditionally doing may not be adequate if we have to cover the larger part of our country. So what I mean to say is that we have had canal systems. We had been using conventional way of laying canals, but then today, when we want to cover the bigger area and the bigger part of the country, we got to in fact plan to distribute to the water by taking it through the tortuous path, which could be a hilly area, which could be a terrain, which could be a valley, and then yet make it available for all the people in the region for the farming purpose. So this is where smart farming takes a precedence, and we got to focus on what's the way that we can yet achieve the efficiency what we need by not compromising on the overall objective. So in terms of smart farming, we have been using latest technologies, which I would still call it as a smart technologies. We have used first time in the country a technology which is LiDAR based, light intensification, the light detection and ranging technology, where we could in fact map the terrains and then the valleys and then the tortuous path that we got to cover to lay the pipes and make the whole project viable through the LiDAR incorporation. So that is one area which definitely needs further attention and further enhancements as far as the smart farming is concerned. In fact, we got to make sure that the pressure to the available to the farmers at the time that is required is very, very critical. The agricultural yield, if it has to increase, the water availability has to be monitored regularly. It's not about giving the ample amount of water, but it's also about making water available at the right time when it is to be fetched to the plant. So that is an important point. And also ensuring that right amount of moisture is maintained in the soil so that the plants can get maximum out of it is another point to be looked into. So there is a lot of smartness that we need to bring in the way we are doing farming, and also to support that kind of a methodology into our operation. So subsequently, industrial and desalination is another area which we have playing big time. Of course, this is all about treating the industrial effluents that is getting generated, and desalination, of course, is a big area which we all know about. Converting the seawater into potable water. Um, so. So with those things in perspective, I would say that we got to evolve in our approach by bringing in Internet of Things, by bringing in better way to communicate the data, by making better use of the data, which unfortunately we haven't focused much yet in our country, because the data is nothing but the wealth, and the wealth of information, and how effectively we will be able to extract information from the data and convert that information into a valuable outcome is the point that we got to consciously think about and start focusing on. So that's something which I wanted to share with you all. And I will turn it over to you, Narendraji, for further questions.
Oh, thanks, Dr. Vijay Sai. I think you have touched upon an important topic. In fact, you have enlightened me on the kind of losses we are talking about. I thought the losses which you are talking about was what I used to hear in my childhood days. And even today, you're talking about 55% losses in transmission for rural water distribution system.
Many cities, many
Yeah,
cities.
I would first give the opportunity to the other two participants to first ask their questions, and then I may have more questions to ask, please.
Sure.
Dr. Abhilasha first.
Okay, thank you very much. So, Dr. Vijay sir, nicely you have mentioned actually all the verticals that come up into this area. And I just want to know your perspective specifically on so using data as you talked about. Um, so what do you think the infrastructure like the smart meters, which Mr. Vikram also talked about, the smart meters or sensors or the monitors, are their availability in India and their uses is a challenge or the way the data from them, how to use that data from analytics purpose and for real-time monitoring and all that is challenge. Like, which is the first step that we should think of to take off?
Yeah, that's a very great question, Abhilasha, and thanks for bringing that up because there may not be just one answer to that, or not just one answer may be the correct answer to that question. But definitely, there are multiple perspectives to this. But I will try to bring up what I feel has been a limitation. So your point is actually correct. That is it the availability of the sensors? Is it the availability of the infrastructure that is limiting us to implement this scheme? The answer may be partly correct. We may have to import certain sensors in that case to bring the necessary amount of accuracy, and the cost of such sensors may be a little prohibitive in terms of the operation and the investments that we got to make it. That is one way to look at it. But at the same time, we are caught up in a very different situation. So whenever we talk about sensors and the smarter way to make smarter way to build the better capability into operation, we always take a step back because we feel that the manpower is so cheap in India. There is so much amount of manpower that is available. So why not use that to the maximum extent to derive the required output? So that is one way typically we feel. For instance, let me take a wastewater treatment plant. It's all about making sure that the quality of the parameter, the wastewater is being met, the influent stream is coming in what frequency, what is the aeration that we are supposed to be using, how much amount of how much time that the waste has to stay in a particular reactor. So it is intense decisions are required in terms of manpower thinking and the people with relevant expertise to make those decisions and make the wastewater treatment plant operational in some particular way. But if we have to go a step ahead, how do we make the plant more efficient? And then how do we get the plant to the best possible level and increase the entitlement to the further level? I think we got to then think about bringing more refined schemes into the operation here. Maybe we should start investing on smarter sensors, the smarter way to monitor the parameters, the smarter way to derive information out of the plant, smarter way to in fact understand what the information is essentially all about and how the whatever the corrective action that needs to be taken. There is a big gap in our system because converting the information into an actionable outcome and conveying this actionable outcome into an operator who has been operating the plant in a conventional way for ages is not an easy thing. There is a kind of an the systemic problem that we got to in fact overcome. Just having a sensor and getting the best possible output is not going to serve the purpose unless we act with an appropriate action, take the corrective action, and there has to be adequate training, there has to be expertise, skills, and those things also have to come up in the system to make those things happen. So these are all the complex issues which we got to deal in a coherent way. Simultaneously, we got to think about handling all the issues in one go. So that's my take, but certainly this is again subjected to some interpretations and understanding by different people in different way.
Dr. Vijay, I had a question.
Sure.
I just wanted to ask you about the acceptance by, like, for instance, L&T is making, infrastructure on behalf of some government agency, CPWD or PWD, or some agency like that. So now, are you in a position to also seed the idea into their, thought process about what technologies are the best? Because so that we have supplied some equipment to the Parliament House, which was a reverse osmosis at the end of a sewage treatment plant. I don't, in 5 years, I've not ever heard of a replacement of a membrane coming in from there. So I am quite sure that the plant is not being used to its best capacity, and something else is, happening. So I am just trying to see that since you are in that position where you could actually influence this, have you seen a mindset change where people, though your user is asking you for a better and newer technology?
No, absolutely right, and that's happening off late. Particularly, as you said, many agencies we are working with, and the conventional methods. Everybody knows that whatever the way we have been doing. I'll give you a very small example here. I talked about the smart farming, and I'm just taking another example. So everywhere, this was whenever we have to, uh, invest on mega lift irrigation projects, right? I mean, where we got to have multiple lifting stations and then you got to pump the water to a higher level. There used to be a survey that was done, and this survey used to be a manual survey all along, and it was not easy to do it in the terrain conditions. You have to go and pitch the pole, use the point by point marking, and then construct the whole topography, and then used it to feed it back to the engineering team to work on the design and get it done eventually. Let's say a project of that nature would cost about 10,000 crores, which is quite huge. And getting this manual survey done itself will be a 2 years exercise. I mean, because of the terrain and the challenges that you got to do with cover the entire area and get it done. So we proposed that there is a better way to do it using the LiDAR technology, which I basically talked a few minutes back.
Yes.
And then there was acceptance because, of course, there is a cost aspect associated with that. You have to spend some money to make it happen because you need to put the laser camera onto a chopper. The chopper has to fly at certain altitude, covering the entire surface and covering the entire area. But the point here was that we could save on the time and we could get better design done in terms of what the overall infrastructure is concerned. There was an acceptance of this, and that whole system is changing now. People are accepting if we are bringing in something new to the table and it has a tangible outcome. Definitely, there is an acceptance that is building up in the system.
Yeah, thank you. Dr. Vijay, I just wanted to, from your experience and number, I thought if I can get you. See, from the times when the industrialization started, many of our large industries like the Aditya Birla Group or the Tata Group and the other kind of large industries which started, they're almost now maybe 30 plus years old, 40 plus years old. And during those days, the civil engineering was to have below ground pipelines, like what we have in the water supply system of rural or the urban areas. My simple question from your experience, can you just throw some number on what kind of losses do you see in the distribution system of an industrial complex versus a rural water distribution system versus a domestic water distribution system?
Well, that's a tough
I mean,
question,
urban.
unfortunately.
Yeah,
Yeah.
yeah.
So, unfortunately, I may not have those numbers
Okay.
right now. But my experience in the context of urban water distribution system has been in the tune of about the 30 to 55%, which I have mentioned there.
Okay.
It's not about the conveying the water from the river, far away into the point of distribution. But once the distribution happens after the main pipeline, the main header, then you will see a lot of leakages. Going unnoticed and being untracked and things like that, which is ending up in huge losses eventually. And that is my thing on the urban water system. But on the industrial and rural side, the values may be similar, but I got to basically get my data right before even making those
Just
statements.
before closing, one small question. This 30 to 55%, these losses, you're not accounting anything for the evaporational losses during storage, right?
No, not evaporation losses during the storage. It is post, you have pumped the water.
Distribution. Yeah, yeah.
Yeah. So X amount of water has has been pumped out. So what has been received at the user
Okay.
end? So that is what I am talking about.
Fantastic. I
Forgetting
understand what you're saying.
yeah,
That's
yeah.
a huge number, and definitely smart metering and use of technology should be a good way forward. Only thing I believe from both of you, one is a manufacturer and other is a user. I believe the cost economics is what's going to drive its use more deeper into the last man on the pipeline.
Absolutely, and that's a very valid point. And this is a interesting point here, because whenever we think about the distribution pattern that we see in India, it has been always intermittent. And whenever we think about why intermittent, people, because people feel that, okay, I just have to pump water or supply water only during the regulated hours, and people should be be able to consume it. But that is adding enormous stress to the whole system here. That intermittent supply is causing all the pipes to break, leak, burst, and because of the anomaly that sets in due to the distribution pressure variations. So when the water starts getting pumped, so first thing for us is to move from that intermittent to continuous water supply 24/7. Once you have that setting, then it is easier to monitor the pressure conditions, the flow conditions, and manage the whole network better, avoid leakages wherever it is happening, and then control the loss of water better. So that is the change that has to happen, and slowly that is coming into the system now.
I appreciate. Thank you very much, Dr. Vijay Sai, for your good talk and your experience speaking through you to the audience today. I will also request you again to share your details on the chat box so that we can have your contact details. Uh, now, I move to the third speaker today, Professor Abhilasha Maheshwari, who is a assistant professor in the Department of Chemical Engineering at the Indian Institute of Technology, Jodhpur. She handles sustainability process systems engineering lab at the chemical engineering department, and she has completed her PhD jointly from IIT Mumbai and Washington University in St. Louis. She has conducted research in many different aspects of water quality management through smart water infrastructure, from performing mathematical modeling of drinking water distribution network to tanker based water supply system. So I now request Mrs. Dr. Abhilasha to take over the stage, please.
Thank you, Mr. Narendraji, for your very generous introduction. I would like to share my screen as I have put some slides to discuss with you all. Can I do that?
Yeah, please.
Let me know if it's there. Is it there?
Not yet. Yeah, now it's there. You can put it on the presentation mode. Yeah.
Yes. Is it okay now?
Yeah, sure.
So, yeah, as we all talk today about various aspects of smart water infrastructure, starting with Mr. Vikram about the word smart itself in the water infrastructure, and then Dr. Vijay Sai about different verticals that falls into this category of a smart water infrastructure. So I would also like to put some perspectives from systems engineering on this topic today, and just want to throw some light on where are we today and what we look in future regarding smart water infrastructure. And before starting, I would like to welcome you all at IIT Jodhpur. Please do visit us whenever you are in Rajasthan. It's kind of a pearl in a desert for us. So we really welcome whenever you have any opportunity to have us here. So I'll skip this with just saying that in addition to water quantity, water quality challenges are also very important. And as per the Sustainable Development Goals of 2030, one of the main focus is to improve water quality and optimize the operational efficiency in water management practices of all our water systems. It can be industrial water system, it can be drinking water systems, or it can be agriculture systems. So at each water system level, we need to improve our operational efficiency in order to target our sustainable development goals. And in that direction, this notion of a smart water infrastructure is emerging. So where the whole value chain of water is actually turning to some digital technology solutions. So as we know that all the buzzwords, industry 4.0 or water 4.0 or internet of water or smart water, so they all are related in this notion of using some advancement in digitalization in today's world for seeking for solution to these water challenges. So in terms of that, the smart water infrastructure has actually three layers when we talk about system. The bottommost layer comes at the physical system, where we have all the sensors or the controllers or the actuators or the valves to run our physical system, as well as all our ICT products for disseminating our data from that physical system to the level where we can use. And that second level is the decision support systems layer. And this layer is basically a sandwiching layer, I would say, which takes the data from physical system and it has all kind of optimization models, data analytic tools, modeling for operational efficiency, quantity, quality monitoring, etc. And these kind of informed decision making, which we analyze in this decision support system layer, that aids to the management and control system, which is at the topmost layer, from where we actually functionalize for real-time control all the components that we have in a physical system. So this is kind of a one systems layer understanding of a smart water infrastructure, and it's valid for all. It's valid for agriculture, drinking water, or industrial anything. So moving ahead, and given this rate of, we can say increased rate of interest in a smart water infrastructure adoption. So recently IWA, that is International Water Association, conducted this survey of 40 drinking water and wastewater utilities across the world to understand what are the different phases of adopting this smart water infrastructure. And they come up with very nice graph that you can see here. So they have divided these phases in 5 layers. First layer is like not started. There are many utilities which are still operational and based on the operator's experience, and many in India too also. Then the basic level of adoption is defined as they have started deploying some online monitoring capabilities like sensors, smart meters, or a SCADA, that all we are talking about. And then comes the opportunistic adoption phase, where they start looking at the opportunities to use the data that is coming from this layer and redesign most of their operations with various automations and control systems, advanced controls, etc. And once this opportunistic layer, there is a sharp increase you can see at the systems level, where we need to develop resources and platforms that can work with this smart water infrastructure. These platforms can be in terms of Internet of Things, it can be AIoT, or the cloud development, etc., and the optimization models, so that we can work with whatever data and control systems we have at the bottom layer. And then at the last, transitioning towards the transformational stage for what we say as increasing the performance efficiency via digital technology. So that comes when we say that our system is really at a transformational stage and it is inspiring other water systems. So I really liked this phases of adoption, and as a result of this survey, the basic level of adoption in the world today is still, sorry, the average level of adoption in the world is still at the basic level only. And but world is rapidly moving towards opportunistic, but there is a huge gap still in opportunistic and systematic layers in the current scenario. So that's why what we do is, like, I wanted to give an overview. So we deal with this layer of system, smart water infrastructure, developing decision support systems in both drinking water distribution systems, and we have also worked on industrial water systems. So I'll just give a brief insight on these two, and then we can discuss all any questions on these things. So the most important drinking water contaminants that can make an impact on enhancing water quality are microbial contamination, heavy metals contamination, and the disinfection byproducts. So if we are able to control, if we are able to improve the control of these three contamination risk in drinking water distribution systems, then we can say that yes, we are towards achieving our sustainable development goals. And that is where we have developed this framework for implementation of real-time control of water quality. So we get input from physical system, as I talked about. Then in this DSS layer, we actually establish various control objectives based on what are our objectives, whether quality, its compliance, or its other things. Then we develop distribution network modeling and optimization resources like models, maps, digital elevation maps, water quality models. Then we also use them to design our monitoring systems like identifying strategic sensor locations, actuators, alert investigations, etc. And that all then helps to the management and real-time control system. So this is what we have trying to propose as a part of a smart water infrastructure innovations. And so this is one of that work which we have got patented, kind of a system and methodology for optimizing the disinfectant doses and large scale water distribution networks, where we have actually designed the decentralized controllers. And now we are in a position to implement this in Guwahati water distribution network through one of the collaborative projects with IIT Bombay and IIT Guwahati. So this is kind of that scheme. And then we have also worked on various other contamination aspects like heavy metals that I talked about. So we worked on water chemistry modeling for lead release and distribution systems. We also worked on simultaneous control of various conflicting contaminants to maintain water quality as it is moving through the distribution systems. Then in tanker, so other than drinking water pipe networks, we also have tanker water systems, which are equally prominent in India, prevalent in India. So we worked on developing some frameworks for efficient planning and management of these tanker systems so that people get quality water at timely aspects. And then this is about the industrial water system where we try to identify some ZLD schemes with minimizing fresh water consumption and some economic benefits over that. And this is some of the ongoing research that we are doing at our sustainable PSC lab at IIT Jodhpur. So this is also one of newest idea of AIoT based smart graded water supply grid. So not looking only at one kind of water, but we are looking at all kind of waters and trying to develop technology interventions to use that water based on the idea that no water is a wastewater. So every water can be used for some or other purpose through some grading in the water supply. And in this direction, we have started work in our IITJ campus network itself. So these pictures you can see, we have started deploying sensors and online monitoring. And sooner we are trying to use this data to start our work on this kind of graded water supply grid. And we are also into setting up a water innovation hub with Fraunhofer, and also L&T is also part of that with us. So these are some ongoing research initiatives, and yeah, thank you. So I would now like to take all the discussions with you all.
Yeah, thank you, Dr. Abhilasha. I think you have spoken about some relevant kind of projects and activities in an institute like IIT that should come out with ready to work engineers out from college. So
Right.
let me first to the Dr. Abhilasha, please.
Sorry, I cannot hear you, sir. Can you repeat?
Dr. Vijay Sai?
Yeah.
Yeah, your session, please. Yeah, any questions from your end, please?
Sure. Yeah. Professor Abhilasha, that was wonderful presentation. Thanks for that. And one question I had was on the heavy metal, what you were highlighting. So definitely that's an interesting topic because in most of our treatment methodology that we follow today, the heavy metal monitoring hasn't been a consideration. So what are the schemes that you are proposing as far as the heavy metal removal is concerned from the water?
Okay. So it's mainly about lead and copper as of now. So the idea is that although you can treat lead and copper at the water treatment plant itself before letting water to flow in the network, but it may not be the India's case, but in US, if you will see, the legacy pipelines are still lead service lines, or they are partially replaced copper service lines. So lead starts leaching from those pipelines, and that is a major challenge there, because of which various Flint and various Ontario public health hazards happened recently. So this kind of a modeling where we can predict the factors which affect the leaching of lead from those distribution pipes, so that we can optimize the water chemistry at the treatment plant itself, so as to not allow that leaching from the pipe. That is the intervention that we were trying to do in that work.
Okay.
Mr. Vikram, you're not audible. I think you're on mute.
Yes.
Sorry, apologies. I
Yeah,
said
yeah.
very
Yes,
nice presentation, Dr. Abhilasha. One thing which was good to note was that normally we have incidents of the pipelines, the sewage pipeline getting burst and it mixes with the drinking water pipelines currently. That is probably because of the vacuum formation in the, we have grown up throughout our lives with having 1 hour of water in the morning, 1 hour in the evening. But increasingly, now with cities now going for 24 by 7 water supplies. What do you think that, I mean, it becomes even more relevant, that the monitoring is done from your sort of perspective to ensure that the water quality remains as good as it is at the treatment level?
Yes. So that is definitely there. Since US has most of the entire US has 24/7 pressurized networks, but still they have a big problem of water quality monitoring there, and water quality at the consumer end. So same thing will be happening in India, even if we switch from IWS intermittent water to continuous water supply. The monitoring of water quality at regular intervals will become more prominent then, and it would be more challenging also then. So yes, intermittent has its own challenges in terms of monitoring water quality. But when it comes to continuous systems, the regular monitoring, because of there are some dead ends in the design itself of the network, where we have a stagnation of waters, or we have a lot of growth, or the this deposition that I was just talking about, leaching of the metals from the pipelines. So all these things do contribute even in the continuous systems also, and that's again where water quality monitoring is relevant.
Okay, thanks.
Yeah, Dr. Abhilasha, I have on your model which you showed just about how you are planning to map or monitor the water distribution system in your own campus using strategically placed sensors. And that is one good example of how academia can train their students while they are in campus. It's a project implemented in-house. But you being a IIT, I from the industry have a sincere suggestion. You should come collaborate with the industry for doing such projects in industrial setup, because that's something which is done by the industry, but not to the fine tuning to the scale which you are talking about. So as manufacturers of engineers of the future, IIT should collaborate with the industries to do such kind of projects is one of my suggestion. But definitely what I should tell you is what Dr. Mr. Vikram also said, with the kind of emphasis on 24/7 water supply by the government, and a large part of it being dependent on the groundwater resource. The management of that resource cannot go the way what Dr. Vijay Sai said about the pipeline system, where 55% up to 55% of water is lost during distribution at the consumer's end. So definitely with the kind of groundwater resource depleting, recharge not really happening, no ponds available for recharge, and the rivers running dry, all of them are compounding to the problem of depleting groundwater. And the more we can save that groundwater, it's going to be available for the future generations. The habits which we are going to cultivate are going to be there for generations to generation. Intergenerational habits we will have to build up. So I hope that the points which you raised, the point which Dr. Vijay Sai raised, and the technologies which Mr. Vikram is trying to bring in to make Atmanirbhar Bharat will take us a long way in managing the water resource. And we really prove the uh, prove the what do you call, the community which is projecting a 50% population in water starved area by 2050. We prove them wrong collectively. So if that can be done, then that's the service we can do for the society, and intellectuals can definitely play a lot of role into that. So it was a fantastic presentation. Was nice to hear Mr. Vikram's entrepreneurship, starting with nobody hearing him, and now he is operating 2,800 RO systems across the country and wanting to grow more, and also wanting to become a manufacturer of membranes. It was very pleasure hearing Dr. Vijay Sai. Every word he spoke was talking as much as his gray hairs experience filled in that. And Dr. Abhilasha, it's a great one. It's nice to know that you are doing practical projects in your site with the sponsorships of the government, which comes to the premium institutes like you, and that will definitely churn out more smart engineers for the smart solutions which the water industry requires. With that, I thank all of you for the time you have taken and the nice presentations, and look forward to interact with you as an industry member wherever possible. We will surely definitely interact with you. With that, I think I will close my part now. Back to the organizer, CII, please.
Thank you, Mr. Jain. Thank you so much. And the way you moderated the session was really nice. Once again, thank you, everyone. It was a wonderful session. Thank you for your time, and we look forward for your engagements in our next tech and innovative initiatives. Have a wonderful day. Thank you.
Thank you.
Thank you all.
Thank you.
Thanks,
Thank you,
everyone.
everybody.
Thank you.
Thank you.
All. Yeah, thanks a lot.